Hello everyone. In this video, we're going to discuss about the virtual memory concept. This virtual memory is one of the important concepts in operating system. So when we talk about operating system, so we should understand, so without the memory concept, we can't able to perform any operation in the machine. If you want to execute any simple computation, you need to store that program whatever you have developed, and before executing it, you have to store it in either internal memory or external memory. So there are various levels of memory that are available: physical memory, secondary memory, external memory, or cache memory, or even registers. So according to the size and the speed of the memory, the levels either grows from bottom up or from top down. So here, demand paging. So before going to these concepts, so I would like to tell about the virtual memory. So what is virtual memory? We have many different levels of memory, that is secondary memory and physical memory. Secondary memory is nothing but the external memory. Physical memory is nothing but the primary memory, which is said to be RAM. Secondary memory is ROM, read-only memory. So what we will do, whenever you want to execute any of the process, initially you will store your process in secondary memory. So when it is needed by the CPU for execution, it will be transferred to the physical memory. So this is the basic concept behind the memory management. So if you are trying to execute any of the process and that particular process is not available in physical memory, what it will do? It will produce an error to the user, that is no memory space, or the process or the program is available in physical memory. Say for example, if you are developing one C program, if you are typing on C program and you need to store that program in the machine. So if you want to store in the RAM itself, but the RAM is not having enough space to hold your program. So what happens? It will produce an error called no memory space that is available. So it is a normal concept. So if you don't implement with the virtual memory, suppose if you implement the virtual memory concept, and again if you are typing the program and you need to save your program, even if primary memory is not having enough space to hold that program, but it will not show error to the user. Okay, instead of showing error to the user, it will show error to the operating system. So from the user point of view, we can understand that the program can able to store in the primary memory. So RAM is having enough space to hold many number of programs, whatever you created. So what it will do, even the primary memory is not having enough space to hold that program, but it will not tell anything to the user. It will intimate to the operating system, and then operating system will take over and it will handle that error. So how it will handle that error? With the help of this virtual memory. So that is what we're going to discuss in this topic. So demand paging. What is demand paging? So there are many memory management schemes that are available. So in order to map the address from the logical memory to physical memory, if the CPU is trying to fetch any of the process or even a single instruction, it will generate one address, and that address is not said to be the absolute address or actual address. It will generate only the relative address, which means the address which is in the logical memory. So it will generate only the logical address and not the physical address. In order to get the actual address, that is the physical address, we have to follow some of the mapping technology to translate the logical address into physical address. So if you're going with the mapping technique, so we can follow two techniques. One is paging and another one is segmentation. Paging means the process, whatever you want to store, that process will be divided into several partitions, and each partition will be stored in set of pages in the physical memory. So in the memory also we will divide the memory into several partitions, and in each partition we will hold some part of the process. Even the entire process will also be stored in any one of the partition. It depends upon the process size. If your process size is very less, we can hold the entire process in one of the partition. If your process size is larger than the partition, then we will divide the process into many number of sections, and all those sections will be stored in several partitions in physical memory. So this is what paging. And segmentation means all those partitions are of different size. That is nothing but segmentation. If the partitions are of same size, then we can call it as a paging. Okay, so here demand paging means, so if you are working with this virtual memory concept, then the user may not know about whether space that are available in physical memory or not. So whichever the program or the process he is developing, all those process will keep on storing in the physical memory. How it will store that in physical memory? Because the size of the physical memory is very much lesser than size of the secondary memory. How it is implementing this virtual memory concept? What it will do? It will produce error to the operating system. Afterwards, operating system will take care of the responsibilities about how to handle that or how to recover from that error. So what it will do, it will search that particular page, whichever is not available in physical memory. It will search it from the secondary memory, and afterwards it will transfer that page into the physical memory for execution. This is what virtual memory concept. It is just showing the assumption to the user that the physical memory is having enough space to hold all the incoming process, but it is not in real. Okay. So here, what is demand paging? So the page which is nothing but any one of the partition which holds any part of the process. So the page that is not available in physical memory, but we need to transfer it from secondary memory. So whenever it is needed by the CPU, okay, when CPU wants to execute that particular page, only at that time, if you are transferring that page from secondary to physical memory, that is nothing but demand paging. We can also say that it is a lazy swapper. So here we are just transferring the programs from secondary to physical, but the physical memory should have some free frames to allot all those pages. So you should have some empty space. If you don't have empty space, so what we have to do, we need to replace any of the old process with the new process, whatever we want to execute. So that is what we are doing. If you look at this picture, we have, this is actually the main memory and this is the secondary memory. Some of the pages we are just swap out from the physical memory because that is already completed its execution. And now some of the pages we are just doing swap into the physical memory because that is currently needed by the CPU for execution. So we are just swapping in operation, and one more operation is swap out operation. This is what swapper. So a swapper is the term which is used to perform the swap operation. And what is pager? Pager is the term which is also performs swap operation, but it will swap only one page currently that is needed by the CPU. While swapper is nothing but it will swap many set of pages at a time from secondary memory to physical and vice versa. So this is the difference between the swapper and pager. Lazy swapper means only if it is needed currently by the CPU, only at that time if we are doing the swap operation, that is nothing but lazy swapper, or we can also call it as a demand paging, right? Now, so next term is page fault. What is page fault? So whenever you are searching any of the page in physical memory, but that page is not available in the physical memory, then we can say page fault will occur in the system. That is nothing but page fault. So how can we find out that page fault occurred in the system? Which means with the help of the page table, we can able to find out whether page fault has occurred or not. So here page table is nothing but each and every process will have their own page table. So with the page table, each and every entry will hold the information about the frame number and also the valid or invalid reference bit. So that bit value will give the information about the page availability in the physical memory. So next one, if page fault occurs in the system, how can we handle that page fault? So if you look at this picture, we can able to find out some of the sequence of steps to be followed in order to handle the page fault. So first one, initially we are just loading one of the process and we are just want to execute that page, right? So we are just checking with the page table whether that page is available in the physical memory or not. If it is showing that it is an invalid reference, then it means the page is not available in the physical memory. If it is showing it is a valid reference, which means the page will be available in physical memory. So with the help of this page table, we can easily find out whether this page is available in physical memory or not. Suppose if it is not available, what it will do? First step is referring the page table. Second step is if the page is not available, then it will produce trap and that will be sent to the operating system. So what is the trap? Trap is nothing but is a kind of error and it is just intimating the operating system to handle that error. So what operating system will do? It will check out whether this required page is available in secondary memory. If the page is available, what it will do? So it will replace or it will transfer that page into the physical memory. So checking that page in the secondary memory is the third step, and the fourth step, so it will transfer that page into the physical memory, that missing page. So already we referred that page is not available, so we are just checking. OS, what it will do, it will check whether it is available in secondary memory. If it is so, then it will transfer that page and it will place in this physical memory. So wherever the free space that are available in physical memory, so in that space it will place that page. And what is the step 5? In step 5, we have to reset the page table. So why we are doing the reset operation with this page table? So already it is noted that invalid reference bit has been mentioned for this particular page. Now the page is available. That particular page is available in physical memory. So we have to change this reference bit to valid. From invalid to valid, so we are just changing it. And finally, we are just restarting that instruction. Right, so we are just restarting that instruction. So what is this instruction? So initially we are just loading this M and we are trying to execute that page, right? So if you are executing any of the process or the page, the first step should be the fetching operation. Right, in the instruction cycle, the first step will be the fetching operation. So we are just fetching that instruction. While fetching the instruction, it is just telling that the required page is not available in physical memory. So we should abort, the operating system will abort that instruction, or whatever the instruction we are just executing at that time, it will abort, which is nothing but terminating that instruction. So it will stop executing that instruction abruptly. That is what aborting the instruction, and it will come across all the sequence of steps, and finally this page table will be reset, and afterwards we are just restarting this instruction in order to execute that instruction again, because now the page is available in physical memory, so we can access that page from physical memory. So this is how sequence of steps to be followed in order to handle the page fault. So if any page fault occurs in the system, then these are all the steps to be followed for handling that page fault, right? So all these steps will be done by the operating system, because we have implemented the concept of virtual memory. So user may not know about whether the space that is available in physical memory or not, otherwise whether the required page is available in physical memory or not. So user may not know any of these details, because the operating system will take care of these things, and it will produce the result according to the process given by the user. So this is how the virtual memory concept is providing the imagination or the assumption to the user that physical memory is having lot of space to hold all the incoming process only to the user, but it is not in real actually. So beyond the process, so these are all some of the steps to be followed by the operating system. This is what the basic concept of virtual memory. Thank you.